Okay, let's continue with Newton's laws of motion. We stopped yesterday at Newton's second law. Newton's second law, when an object of mass m is acted upon by a net force or sum of force, all forces acting together, the object will accelerate. What does it mean? Now, in Newton's first law, we said that if an object at rest will stay at rest unless an unbalanced force acts on the object. What does it mean, unbalanced force? Unbalanced force, or the sum of all forces or not force, it means what? That the forces, for example, on the x-axis, they are not equal and opposite. They don't cancel each other. It means that the object is not in equilibrium. This is the meaning of unbalanced force. For example, it means that the applied force to the right is greater than the friction force. Okay? So the object is accelerating. This is Newton's second law. So, in any question you see that there is acceleration, it means we are talking about Newton's second law. If the object is at rest or an object moving with constant velocity, it means that this object is not accelerating, so acceleration equals zero and net force equals zero. Is it clear? So, the acceleration of the object will be in the direction of the net force. Acceleration and net force the same direction. The acceleration is directly proportional to the net force. So if the net force increases, it means the object will accelerate more. If the net force decreases, the acceleration will what? Decrease. Okay? The acceleration will be inversely proportional to the mass of the object. Now, let's say with the same amount of force. Okay, I applied the same amount of force to two different objects. The object with less mass will accelerate more, and the object that has more mass will accelerate less. So, what does it mean? That acceleration and mass, they are inversely proportional. Okay? Let's read together. Newton's second law results in several important consequences. Number one, when all one-dimensional vector forces sum to a non-zero value, the forces are said to be unbalanced. Here is the meaning of unbalanced again. When we add the forces, the answer is not zero. It means they are not equal and opposite. The result is acceleration, which alters either the magnitude or direction of velocity. We said acceleration means change in speed or direction. When an object is accelerating, there must be a net unbalanced force acting on the object. Number two, the direction of acceleration is the same as direction of the net force. It's clear, easy. 3. The direction of velocity is not necessarily in the same direction as acceleration. This is very important. Velocity and acceleration not always in the same direction. Acceleration and force always the same direction, but velocity and acceleration no. How? An example would be the change in velocity of a car as it slows to a stop. So a car is moving forward, okay, or to the right, let's say. A car is moving to the right. But the car is slowing down and the speed is decreasing. So in this case, what happens? The car is still moving to the right, but the speed is decreasing. In this case, the acceleration is in the opposite direction. Okay? The acceleration is in the opposite direction. When vector forces add up to zero, the forces are balanced. This is the meaning of balanced forces or equilibrium. When we add the forces, the answer is zero. It means that the forces are equal and opposite in direction. There can be no acceleration. An object will continue at constant velocity based on the first law of motion. So, when the object is either at rest or moving at constant velocity, the one-dimensional forces acting on the object must cancel each other. The net force must equal zero. So, Newton's first law, we are talking about balanced forces. net force equals 0, the object at rest or moving with constant velocity. Newton's second law, we are talking about the object accelerating. Net force doesn't equal 0, okay? It equals to mass times acceleration. Net force equals to mass times acceleration. Newton's second law. Here we call this force unbalanced forces, okay? Let's see, we have here examples about Newton's second law. Remember, the formula for Newton's second law is what? F equals mass times acceleration. Here's the formula again. Sum of forces or net force equals mass times acceleration. This formula is very important. We are going to use it from now till the end of this semester. Okay? Don't forget it. Sum of forces equals mass times acceleration. Let's read the first question. Try to solve it together. The net force on the propeller of 3.2 kilogram model airplane is 7 Newton forward. What is the acceleration of the airplane? Simple, direct, clear. The mass is given 3.2 kilogram. Let's look at the steps. Net force 7 Newton, mass 3.2 kilogram. Find the acceleration. We will use Newton's second law. They're asking for acceleration. The force and mass are given. So we substitute in the formula and we find the acceleration. The answer is 2.2 meter per second square forward. You have to write the direction for acceleration. You have to write the direction. It's in the question because force and acceleration, they have the same direction. Okay? Sorry, here by mistake I forgot to copy it to write it, but you have to write forward. Good. Question 2 and 3, try to solve them by yourself and to make sure that you got the idea of this law and this formula. Let's continue now with Newton's third law. Newton's third law, I think that you all remember this law. It is what? Every action has an equal and opposite reaction. Newton's third law states that when an object interact, an equal and opposite force is always exerted between them. Look at these 3 examples. Now the book is on the table, so the book is applying a force on the table, okay? At the same time, the table applies a force on the book at the same time, at the same moment, in the same magnitude, opposite direction. This is Newton's third law. Here, if you push the wall with your finger, if you apply a force on the wall with your finger, the wall also will apply a force at the same time, what? Opposite, but equal to the force from the finger. And also in this case, the same. Action, reaction. Okay, always equal in magnitude, opposite in direction. For example, when a person jumps upward, he or she creates an equal downward force on earth. Good? When you try to jump, what do? You push with your body on earth, okay? Anyone witnessing this event would observe the person moving upward but would not detect earth moving at all. Okay, you will see that the person applies a force on earth, so the person will fly or jump toward up, moving toward up, but the earth will not move. How? How that happens? You said, teacher, that action and reaction, equal force and opposite direction. Why, when the forces are equal, does Earth not experience an equal and opposite motion? Because Earth has an enormous mass and inertia. You can't compare the mass of Earth with the mass of the object or the person. Therefore, the planet is extremely difficult to accelerate. The force exerted by the person jumping is enough to lift the person off, but the ground does little to the motion of Earth. Okay? There is action and reaction in this case, but only we will feel and see the acceleration of the object or the man, not the acceleration of Earth because of different masses.